In this video we're going to have a look at factorising expressions. So factorising is the opposite of expanding. In the last video, or the last section, we had a look at expanding x and let's say x plus 2, for example. And if we were to expand that, it would go x times x gives us x squared, x times 2 gives us 2x. Alright, so that's expanding. Factorising is going the other way. It's saying, alright, we're starting with x squared plus 2x and we're going to factorise it into an expression with brackets. Alright, let's say we had 7x plus 14. Alright, to be able to factorise, we need to look for the highest common factor between each of our terms. So we've got a highest common factor. If we have a look at 7x and 14 as individual factors, what is the highest common factor between them? Well, the factors of 7x are 7 and x. Okay, there's not many there. The factors of 14, technically speaking, we've got 1 and 14, doesn't really help us too much. So just think of the ones that don't include 1. So 2 and 7 are the only two factors. Basically, from this list, you can look at each of them and identify which one's the highest number in them. Okay, in this case it's a 7. So that is our factor that we are going to multiply outside the brackets. Inside the brackets we say, okay, 7 times what will give us our first term in the expression 7x. So 7 times x will give us 7x. And then we say 7 times what would give us 14. The answer in this case is 2. Well, positive 2, because we've got positive 14. So factorising 7x plus 14 gives us 7x plus 2. Let's have a look at another example. Let's say we've got minus 3x, take 12. Again, looking for the highest common factor between minus 3x and minus 12. If we were just to look at 3x and 12, okay, ignoring the negative sign for a moment, our factors of 3x would be 3 and x. The factors of 12 would technically 1, 12, 2 and 6, or 3 and 4. Okay, so those are our factors of 12. You can see that we've got a 3 in both of these, so that's going to be our highest common factor. When we're dealing with negative numbers, however, if both of these are negatives, all our factors become negative. Okay, because they're the ones we're going to look for. So in actual fact, we're actually looking for minus 3. So minus 3 is our factor, and we say, what do we multiply minus 3 by to get minus 3x? The answer in this case is x. We've got minus 3 times what gives us minus 12. 3 and 4 give us 12, and because I've already got a minus 3, this must be a positive because my answer needs to be negative. A negative times a positive will give me a negative. So the answer is x plus 4 in the brackets. Let's say we've got 20a squared plus 30a. So we'll just change our variable, same process, it doesn't matter. Okay, so we've got 20a squared and 3a. Alright, so the highest common factor, okay, if you need to, jot them down, 20a squared and 3a. So the factors of 20, you've got 5 and 4, 10 and 2, okay, but the factors of 3, it's just going to be 3. Alright, so there isn't actually any factors between 20 and 3, so we're just going to ignore those for a moment. But a squared, okay, the factor of a squared, we've got a. Okay, a is in both of those. So our highest common factor between them is just a. Okay, so we're just going to take a as a factor and say a times what gives us 20a squared. Well, we're missing a 20, so that has to be the coefficient. And a times a would give us a squared, so it's 20a. A times what gives us 3a? Well, the answer is 3, so plus 3. Some different kinds of factoring is when we have two sets of brackets. Let's say I've got 2x take 1, x plus 1, sorry, take a x plus 1. Slightly different. This time I'm thinking to myself, okay, what are the actual factors we're dealing with? We've got 2 and x plus 1. Alright, that's the two factors. Over here, the other ones are a and x plus 1. Now, in the brackets, these expressions are the same. So what I can actually do is take that as a common factor. Okay, that becomes the factor between these two expressions. So I say to myself, x plus 1 times what gives me 2x plus 1. Well, the answer in this case is going to be a 2. And x plus 1 times what gives me minus a x plus 1. Well, it's actually a minus a. Alright, so again, just as I said earlier, when we're expanding brackets, we get our expression. Alright, this expression is very similar to our first few steps when we're expanding binomial products. So if you need to have a look back over those, okay, if you were to expand this, so this is the first line of working you would get. Okay, so just as a side note there. Alright, so that's factorizing expressions. In the next section, we'll have a look at factorizing some perfect squares.